This lesson shows how to graph the rational function 2x plus 2 over x minus 3. In previous lessons, you learned about the four important parts of a rational function. The vertical asymptote is a vertical line where the function is not defined. The graph curves up or down as it approaches its VA. The horizontal asymptote is a horizontal line. The graph approaches away from the VA, curving down from above or up from below. The y-intercept is where the graph crosses the y-axis, and the x-intercept is where the graph crosses the x-axis. This lesson shows how to graph the rational function y equals 2x plus 2 over x minus 3 and variations of that function. The VA is the zero of the denominator. Set the denominator equal to 0 and solve. The VA for this function is the vertical line x equals 3. For this rational function, the numerator is degree 1 and the denominator is degree 1. Since the degree of the numerator and denominator are equal, the HA is the ratio of the leading coefficients, 2 over 1. So the HA for this function is the horizontal line y equals 2. To find the y-intercept, evaluate the function for x equals 0. This gives 2 over negative 3. So the y-intercept for the function is the point 0, negative 2 over 3. The x-intercept is the 0 of the numerator. Set the numerator equal to 0 and solve. To do this, subtract 2 from both sides and divide by 2 for x equal negative 1. So the x-intercept for the function is the point negative 1, 0. Next, calculate at least one point on either side of the VA. For x equal 2, y equals negative 6, and there's a point at 2, negative 6. For x equal 4, y equals 10, and there's a point at 4, 10. Since the point 4, 10 is so close to the edge of the graph, you should calculate another point. For x equal 5, y equals 6, and there's a point at 5, 6. Finally, sketch a graph of the function. From these points, you can see the function is decreasing as it approaches the VA. So the function must curve down towards the VA and up from below towards the HA. From these points, you can see the function is increasing as it approaches the VA. So the graph must curve up towards the VA and down from above towards the HA. So sketch the graph of the function like this. Here are some variations of the function. Multiplying the entire function by 2 stretches the graph vertically. Notice how this branch of the graph has moved upwards. Multiplying the entire function by 1/2 shrinks the graph vertically. Notice this branch of the graph has moved downwards. Multiplying the entire function by negative 1 reverses the graph vertically. Notice this branch of the graph is increasing instead of decreasing. If x minus 3 in the denominator is replaced with x minus 1, the graph shifts to the left. The VA is now at x equal 1 instead of x equal 3. This lesson showed how to graph the rational function 2x plus 2 over x minus 3. And this lesson was brought to you by the Math Fun Academy. Its continuing mission to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.